Hey everybody, today we are going to do the even numbered problems on the probability chapter review backside or second page, depending on if you just printed it separately. Sort of a bonus video, just to make sure everybody is completely ready to go before the test. This one especially goes out to period 9. Shout out to you. I want to make sure we are really rolling here. We're good to go. Alright, so if you watched the previous video, we did all of the odd numbered problems. So here, we should be able to do all of the evens and be good. Alright, number 16, we're talking about an auto manufacturer that's offering all of these different varieties of car. There are 7 models. Let's make that darker here. There are 7 models. There are 5 different colors. There are 6 different upholstery fabrics and 3 interior colors. Now, obviously, there's way more than that when it comes to options in a car, but we're just going with those numbers to see what we get. 7 times 5 times 6 times 3. Throw that in a calculator. Multiply them all together. This is an example of the fundamental counting principle. Okay. And I bring that up because you've got all these separate categories and you're choosing one out of each category. So you end up getting 7 times 5 times 6, which is 210, times 3 is 630 varieties of car. Alright, next up. Number 18. A vocational school gives courses in typing, shorthand, transcription, technical writing, and accounting. All sort of business style classes. In how many ways can a student arrange a schedule if they must take a course first, second, and third period? So we are implying that you can take any of these classes, any class period, but you have to take business classes first, second, and third period. So what do? Well, it looks to me like you've got 5 different ways you can choose a first period class. But as soon as you have chosen a class, you're not going to choose that class again. I mean, that would be pretty strange if you took the same class twice a day. So you only have 4 options for the second, which means you only have 3 for the third, which means there are 5 times 4, which is 20, times 3 is 60 ways that you can arrange your schedule. Alright, let's keep it going here. We're talking about a bag of Skittles. Without looking, what is the probability that you'll choose a green Skittle? Alright, now we're looking at the bag here. Just on the outside of the bag, we're looking at a regular bag of Skittles. We've got how many Skittles inside the bag? Well, you've got 13 and 17, which is 30, plus 9 is 39, plus 4 is 43, plus 7 is 50. And then out of the 50 Skittles in the bag, we want a green Skittle, so there is a 9 out of 50 chance that you will choose a green Skittle. Alright, now, if you were to take a calculator, see that right there? Alright, that's the power of video right there. If you take a calculator and you actually type in 9 divided by 50, you get 0.18, which is the same as 18%. So there is an 18% chance that you will choose a green Skittle out of this particular bag. Alright. A number wheel is divided into 20 congruent sectors numbered 1 through 20. You spin the wheel and record the number. Find the probability of the following situations. So you've got, if we're doing the evens here, you've got a 2-digit number being spun. So if you think about it, if you have a wheel from 1 to 20, what is the probability that you'll get a 2-digit number? A lot of students, right off the bat, they think there are 10 two-digit numbers between 1 and 20. And if you slow down and actually write it out, you're going to realize that that's not right. Okay? Here's why. You've got the number 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But that's not 10 options. If you count those up, that's actually 11 different numbers. Okay, you've got 11 through 20. There's 10 numbers right there, and then there's also the number 10. So there are 11 different options out of the 20. It does say write your answer using percents and fractions, so we're going to do 11 divided by 20, which would be 55%. All right, the spin comes out to an even number. Well, that makes me happy. That one's not nearly as scary as the other one, because if you think about numbers, half of them are going to be even. The only time that actually runs into trouble to just take a shortcut and just say, hey, half of them are a certain thing, is if you're given an odd number of possibilities to begin with. You know, like let's say your spinner was from 1 to 5. Only 2 of the 5 numbers would be even, because 2 and 4 would be even. 1, 3, and 5 would be odd. So 1 out of 2 is just going to be a plain old 50%. I'm not going to spend any more time on that one than I have to. All right, 26. You spin 2 consecutive odds. Now, here's the thing about a spinner. Your probability doesn't change. If the probability of spinning an odd number is 1/2, and then you spin the spinner again, probability is 1/2 again. Okay, it's not like when you draw a card out of a deck, and then you leave that card out, and then you draw a new card. Because if you don't put the card back, then your probability is going to change. And we're going to get into that here in just a second. Last one. 5 straight even numbers are spun. So now you've got 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Okay. So I'm not going to bother. Well, you know what? Why not? Just so you can see and we can make sure we don't make any silly mistakes. I really don't want to have any silly mistakes here. 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Well, 1 times 1 times 1 times 1 times 1 is 1. All those 2's multiplied together are going to give you 32. Now, as a percent, we'll just round it. We're not going to get a very pleasant number, 1 out of 32. Ooh, boy. So if we were to take that decimal and move it over 2 spaces, you would end up getting a 3.1% chance of getting 5 straight even numbers. All right, you pick a card from a deck of cards, you keep it in your hand, and then you pick another. Find the probability, and we're going to jump to number 30. Both cards are diamonds. All right, now, we've gone through a deck of cards here before. In the one video, I actually pulled up a screen with all the different possible cards. If you remember right, out of the 52 cards in a deck, 13 of them are diamonds. Now, as soon as you have a diamond in your hand and then you're hoping for another diamond, your chances of having another diamond are actually slightly worse because you already have one. Instead of there being 13 diamonds left in the deck, there are 12. And instead of having 52 cards left in the deck, there are 51. Okay, so that's where the math gets a little bit trickier. Now, if you have this tool right here, I want to show you something. 13 over 52, it will probably not surprise you that 13 out of 52 is 1/4. Okay. Now, one of the cool things that this calculator does here is it will actually reduce any fraction, even the ones that you're not quite sure about because they look really, really ugly. So 12 out of 51 reduces to 4 over 17. Okay, so that's going to give you 1 over 4 for the first fraction, 4 over 17 for the second fraction. And by the way, in one of my other videos, I went over how to find this particular calculator if you're interested. I'm not sure if Desmos has any options for this, but the calculator that I'm using right here is actually completely free, and you can download it for yourself using ti.com. And if you were to click on the tab that says products, they're offering free trials because of our current situation of staying at home and having school from home. So just something to help you out. So anyway, sorry, I get sidetracked here. 1 over 4 times 4 over 17, it eventually reduces to 1 over 17. Okay, I can show you why here just real quick. And I don't mind doing this because we're going to have to reduce the fraction, or we're going to have to do a percent from this anyway, so it doesn't really matter. So you got that. And long story short, the reason why is because the 4's cancel out. You end up with a 4 on bottom, and you end up with a 4 on top, and so they cancel out. That's where the 1 over 17 comes from. If we go back over there, we already have the percent. It is about 5.9%. So if you have 2 cards in your hand, there is a little less than 6% chance that they are both diamonds. All right, we got just a couple more. Both cards are aces. If you've played any poker before, you know that's what you want. The problem is, out of the 52 cards in the deck, only 4 of them are aces. And not only that, as soon as you have an ace, the probability that the other one is also an ace would be 3 out of 51. So this isn't looking very good for you because you only really have a 1 out of 13 chance of the first card being an ace. And you only have a 1 out of 17 chance of the second card being an ace. So then when you multiply, you find out that the probability that both of them are is 1 out of 221. And if you put that in a new perspective, that is going to be less than 1/2 of 1%. As a percent, even after you move the decimal over 2 spots, it's still going to be less than 1/2 of 1%. So all the people that complain that they're unlucky, part of it is it just doesn't happen very often. I mean, if something has worse than a 1 out of 200 chance of happening, don't get your hopes up. All right. Last but not least, the cards are the same suit. Now, I'm going to show you a way of looking at this that might be a little bit different. There are actually 2 ways of doing this problem. And so depending on how time looks, I'm going to go over one of them and maybe I'll consider the other way as well. The cards are the same suit. So here's the magic to getting this problem right. So you're talking about the probability of getting the same suit with your second card that you did on your first. And here's the magic of it. The first card doesn't matter. Because the question said, what is the probability that the cards are the same suit? So it doesn't matter what suit your first card is. All that matters is that the second card matches it. So the first card, the probability of getting the first card to be what you want is actually 100%. It doesn't actually matter what you got first. The second card will have a 12 out of 51 chance of matching the first card. So that's it. You don't have to worry about multiplying anything out because the first card could be anything. You reduce that, and you end up getting 4 over 17. And then if you were to do 4 divided by 17 on the calculator so that you could get yourself a decimal, you would get, 23.5%. Okay, so you got 23.5%. So a little less than 1 out of 4. Okay. Now, another way of doing it is to break it down by suit and then do the problem 4 times. I don't want to do that right now. This video is long enough as it is. But you would find out that you have a 1 out of 17 chance to do it for clubs, and then 1 out of 17 for diamonds, and 1 out of 17 for hearts, and 1 out of 17 for spades. And then you would just do 1 out of 17 plus 1 out of 17, and you do that 4 times, and you would end up getting 4 out of 17. Either way, you're going to get the same answer. I just wanted to show you a different thought there. All right, well, I hope this helps. You should be covered for the entire probability chapter review now, and you should be ready to go. Thanks for watching. I'll see you next time.